Hello, everyone, and welcome to the second part of mobile equipment power rolling resistance. So let's first focus on this concept. What is rolling resistance? So imagine you have a machine and you're moving on a level surface. It means you're not going up the hill, you're not going down the hill, and your speed is constant. Okay, so there is some resistance on the road surface against the machine. When the machine wants to move. That is called rolling resistance. Therefore, rolling resistance is the resistance of a level surface. It means there is no grade, with zero grade, to constant velocity motion. It means there is no change of speed. You're moving at a constant speed on a level surface. The resistance of that surface against moving is called the rolling resistance. It comes from the friction between the machine and the surface, okay, the supporting surface. And obviously, it depends on the type of tire, the size of the tire, the thickness, the tread of the tire. Is it full tread or is it used or in poor condition? So I will discuss this in the next slide. So there are some criteria that define the rolling resistance. So, like I said, it varies significantly with the type and condition of the surface. So, on the surface over which a machine moves. So, if you're talking about this area where the tires meet the surface, whatever happens here creates the rolling resistance, okay? So let's get into more details. Let's dive into more details. What type of soil offers a higher rolling resistance? Can you make a guess about this? To give you a hint, do you think, is it easier to walk or run on a soft surface or on a tough surface? Is it easier to play volleyball on an asphalt pavement or on the beach, on sand or very soft surface? So obviously, if you have tried it, you know that playing or walking on a soft surface requires more power, okay? So the answer to this question is soft earth offers a higher resistance. When we say it is more difficult, it means the resistance against motion is higher. In other words, the rolling resistance for a soft surface is higher than a tough surface. For a machine with pneumatic tires, okay, what does the rolling resistance depend on? As you can guess, if you're talking about tires here, so it could be the size of the tires, the pressure of the tires, and the tread. It means the tread design, okay, or how new is the tires. So the size, the pressure, and the tread design will have an impact on the amount of rolling resistance. But how is that impact? So starting with size, bigger size is better or smaller size. So bigger size usually offers, less rolling resistance, okay? How about the pressure? So for crawler track equipment, what does the rolling resistance depend on? Before we get into pressure and tread design, how about a crawler track where there are no tires? So in this case, only the road surface condition identifies the rolling resistance. Yeah, it's the type and condition of the road surface because there are no tires involved. How does the tire pressure impact rolling resistance? So do you think higher pressure is better or lower pressure is better? The answer is if the road surface is soft and the tire sinks into the earth, okay, a broad tread, low pressure tire will offer a lower rolling resistance. It's very hard to pronounce. Lower rolling resistance than a narrow tread, high pressure tire. To make it simple for you all, so we're looking to decrease to lower the rolling resistance, we want the tires to have a lower pressure and a broad tread design. Okay, it means the broader is the tread design and the lower is the pressure of the tires, you will need less power to overcome the rolling resistance. And obviously, the narrower are the treads and the higher is the tire pressure, you will require more power to resist the rolling, to overcome the rolling resistance. How does an aero tire create higher rolling resistance? So it is, it's narrow. How does a narrow tire create higher rolling resistance? So what do you guess? Can you guess the answer to this question? Do you think narrower tires generate a lower rolling resistance, or do you think thicker tires will generate a lower rolling resistance? So to answer this question, imagine you are biking on the beach, okay? With so your bicycle, if it's if it is for a competition, or if it has very thin tires, very narrow tires, okay, will it be more difficult to bike on the beach? Or if your bicycle has thicker tires, it will be more difficult. If you have had the experience of biking on the beach, we're talking about beach so many times today because we want to mention a soft surface, and many of you have experienced this. So moving with a narrow tire on the beach is a lot more difficult than moving with a mountain tire with thick tires, okay? Mountain bike with thick tires. This means a narrow tire would sink farther, okay, into the earth. That makes sense, right? Because when it is narrow, you would sink deeper or farther into the earth. So you have to overcome a lot more resistance compared with the time when you have thicker tires. So obviously we want to reduce the rolling resistance, because the lower is the rolling resistance, your machines can move faster, there will be more productivity, and you can get the job done more quickly, okay? So we are interested to reduce the rolling resistance, but how to do it? First thing is stabilize the material, okay? The more stable your material is, means when they are tough, when they don't move under the tires, then there will be less power required to move over the surface. In other words, there will be a lower rolling resistance. Also, keep the moisture content near optimum. This does not, so what it is saying is that we are not interested in increasing and decreasing the moisture content to a limitless. We cannot say the lower is the better or the higher the moisture content is the better. We need the optimum moisture content. And you know why? Because at optimal moisture content, you get the best compaction, okay? And the better compaction you get, the more stable is your soil, and therefore there will be a lower rolling resistance. Okay. So if you do these two things, although it's not a pavement or concrete, the rolling resistance you get when you have a well-compacted soil at optimal moisture content, the result is a very low rolling resistance, which is as good as concrete or asphalt road. All right. So you might ask, how does rain falls? So we are in a wet area. Many of you will work in Washington State, where we receive a lot of rainfalls. So how does the rainfall impact the rolling resistance? Can you make any guess? So here is a muddy. So the first consequence of rainfalls is the mud, right? So where it gets muddy, it gets sticky, and the tires have they need more power to overcome the rolling resistance. So rainfalls increase rolling resistance. Remember that. It is because they are above the moisture content. What machines are required to keep the haul road in good condition? Okay, so specifically for a grader, water truck, and rollers, you need to take care of the surface condition. Okay, so you want to maintain it in good condition to keep the productivity. It means the productivity of these three machines is significantly impacted by the rolling resistance. There are graders, water trucks, and rollers. So here is a professional advice. You should spend money for keeping a grader at all times, okay, to keep the road surface in good condition. If you want to save money, it is a bad idea. It is a bad idea to cancel a grader. So you think you're saving money, but in fact you're not, because many equipments are passing over the surface, the construction site surfaces, tons of times, right? So if there is higher rolling resistance on the road, the result is less productivity, less speed, and this means more money. So it pays off to spend some money on maintaining the surface condition. All right, here you see a table with rolling resistance for various types of wheels and crawler tracks. So roller resistance is measured in pounds per ton, which is the US ton, or kilogram per metric ton. Okay, so these two numbers are for the same thing, but they are in different system of measurement. So the table specifies different types of surfaces, from smooth concrete, good asphalt, and other types of surfaces, and also different types of tires. Okay, and for each case you have two numbers. Again, one of them is pound per ton, the other one is kilogram per metric ton. So here are the numbers. You will use them in solving the problems. But there is another way to compute the rolling resistance. There are two cases. Case one is when tire penetration is unknown. It means you don't know how far your tires sink into the soil, into the earth. Okay, so it is unknown. We have not measured it. In that case, the equation you would use is this. Okay, but what is P and what is W? R is obviously the rolling resistance that we're trying to find. Okay, and it is in pounds. So P is the total tension in tow cable, also in pounds. Okay, it means if you want to tow, okay, if you want to tow the machine, how much tension you will require, okay, how much force you will require to do that job, okay. And W is the weight, gross weight of the mobile vehicle in US tons, because we're talking about pounds, so this one should be US tons. So what do you understand from this? The weight of the machine and the rolling resistance have a reverse relation, right? Means the higher is the weight, the lower is the rolling resistance. I could feel this when I had a sedan car, okay? I had a Honda Accord previously. So it's a very light machine. I mean, not very light, but almost light machine. And I had a lot of hard times in Pullman because it would not move on the snow, okay, because it was not heavy enough. But when I got a heavier machine, it could move on the same surfaces easily, okay. So there are other factors involved, but one reason was the weight of the car. So technically, for lower rolling resistance, you need heavier cars or machines. So the second case that I talked about was when the tire penetration is known. We know how deep the tire sink into the soil or into the earth. In that case, there is an empirical equation. So tire pressure, rolling resistance, tire penetration, the tire penetration is directly connected to rolling resistance. And that makes sense, right? It means the higher, the deeper is the tire penetration, there will be a higher rolling resistance, right? So when your machine gets stuck, it actually, there is a lot of tire penetration. So there is a great deal of rolling resistance. That's why your machine it is difficult to get out of, very got stuck, right? So it is directly related to this, but what is this one? This one is gross vehicle weight, okay? Gross vehicle weight in US tons. So you might say how the gross vehicle weight here had a reverse impact, and here it has a positive impact. So in fact, this is getting multiplied by the tire penetration, right? Means for a light vehicle, even if there is some penetration in the soil, you don't need a lot of rolling resistance to make it move. But for a very heavy machine, let's say it is 3 inches, into the soil. It has penetrated into the soil for 3 inches, and it is a very heavy equipment. So there will be a lot more rolling resistance against its moving, right? So this is why here you can see this is getting multiplied, because you are actually multiplying this by the tire pressure, okay? All right. So we covered rolling resistance, but there is another resistance against the movement of the machine, and that is the grade resistance. So look at this picture. Obviously, this machine has a harder time to go up the hill than it would when the road surface was level. Okay, so when it wants to come back down the hill, it will have an easier time compared with a level surface. So it could positively or negatively impact the machine's performance. Okay, so based on if it is a positive grade or negative grade, and if the machine is moving upward or downward. So the combination of grade resistance and rolling resistance is the total resistance. So we are talking about 2 types of resistance. We covered rolling resistance, and now we're talking about the grade resistance. Okay, what is it? The force opposing movement of a machine up a frictionless slope. Okay, so when we say frictionless slope, what does that mean? It means we are not considering the impact of the friction, okay? We consider that there is no resistance, there is no friction resistance, we're just talking about the grade. So does grade resistance depend on the type of machine tires? Can you make a guess here? Does it depend or does it not? So we're talking about, our assumption is that a friction slope, so we're not talking about the tires. So no, it is mainly dependent on the weight of the machine. Okay, so the grade resistance is connected to the weight of the machine. It's very important. So grade resistance is related to the weight of the machine. So how does grade resistance change with changes in the grade? Can you make a guess? So obviously in going up the hill, there will be increased grade resistance, and going down the hill, there will be decreased grade resistance, okay? And the steeper is the slope, the more significant is the impact on the grade resistance. So what we learned here is that the second type of resistance is grade resistance. It does not depend on the type of tire because our assumption is that there is no friction. It is directly dependent on the the weight of the machine. So how to show and compute the grade? So there is a method called gradient in percent. Okay, the method is called gradient in percent. What is the definition of that? With a 1% slope, for every 1% of slope and every 100 vertical movement, okay, I mean, every 100 vertical movement, the variation, okay, the vertical variation of 1 feet is what is, let's put it this way. When we say it is 1%, when we say the slope is 1%, so we are not talking about degrees. On the field, everyone addresses slopes with percentages. 1% means the surface rises or drops 1 feet vertically in a horizontal distance of 100 feet. Okay, so if it is 1% after 100, it's a little difficult to type or with the mouse or to draw with the mouse. After 100 feet, your surface will go one foot high, or if it is a negative slope, it will go 1 foot down. Okay, this is what we mean by that. So there is an example here. Let me erase this for a second. Okay, so example here is if the slope is 5%, the surface rises or drops 5 feet per 100 foot of horizontal distance, right? So you can get the meaning, right? So if it is 5% after 100 feet, you will go 5 feet up or down, depending on the sign of the slope, plus or minus. Obviously, if the surface rises, the slope is defined as plus. If it drops, the slope is defined as minus. What does the grade resistance depend on? It depends on the grade of the road, okay, and the machine's direction of travel, okay. So this surface, okay, is not enough if you know the percentage of the slope is not enough. It will vary if the machine is going down or is going up, okay. So depending on that, you will see different grade resistance. All right, so what is the rule? For slopes less than 10%, the effective grade is to increase for a plus slope or decrease for a minus slope. Okay. The required tractive effort by 20 pounds per gross tons of machine. It means for every so first of all, this rule works when the slope is less than 10%. Okay. The effect of grade is to increase for a plus or decrease for a minus the required tractive effort by 20 pounds per gross tons of machine's weight, okay, for every 1% of grade. So we can easily put it in an equation. It means, let's do next example. It's actually about this, computing rolling resistance for grades lower than 10%. For example, so this is the equation. It changes 20 pounds per US tons for every 1% of grade, okay? So let's say if it is 5 degrees, going up, or 5%, sorry, 5% going up or 5% going down, you should just multiply it by 20 to find the grade resistance. All right. So now that we covered the rolling resistance and the grade resistance, okay, this is grade resistance. I will correct it before posting the slides, but computing the grade resistance for grades lower than 10%. So we covered the grade resistance and rolling resistance. The summation of the two is called total resistance. So when you add the rolling and the grade resistance, the summation gives you the total resistance. So we can convert the rolling resistance. So, all right, let me explain. So grade resistance is explained in percentages, right? We just did that, right? Grade resistance and the rolling resistance. So I mean, when we're working with the grade, we measure it with percentages. Okay. Now, the rolling resistance was in a different measurement. Okay. So now we can convert the rolling resistance to an equivalent gradient. Okay. So these two will be of the same type, so they could be, they could be added, they could be summed, or they could be subtracted. We need to convert the rolling resistance into the equivalent gradient before we can add or subtract it with or from the grade resistance. All right, so to do that, when you have the rolling resistance, which is in pound per US tons, you simply divide it by 20 pounds per US tons, okay? This is an empirical equation, and it's very easy to use. So you simply divide it by 20, and then it is working like a slope. So if you're following me, for example, let's say it is 100. Let's say the rolling resistance is 100 pound per US tons. Okay. Therefore, it is working like you are going up a hill with 100 over 20, or 5%. The equivalent gradient of a rolling resistance of 100 pounds per US tons is equal to driving up a hill with 5% grade. Does that make sense to everybody? Okay, I cannot hear you, but I assume it as yes. So by combining the rolling resistance expressed as an equivalent grade, so this is now in equivalent grade, and the grade resistance, the gradient in percent, total resistance is stated as an effective grade. Okay, so the total resistance, also the number that we find by adding this together or subtracting them from one another, the number is again an equivalent grade. So we are considering that there is zero resistance, but there is a grade. Okay, so the combined impact of the rolling resistance and the grade resistance is converted into the equivalent grade. So we consider that there is no rolling resistance, but there is a higher slope, or a higher grade. Okay. All right. Now let's take a look at this. The effective grade on the tractive effort of vehicles. So obviously, as the slope increases, the tractive effort will increase as well, right? So these two numbers are for the same slope, but they are in different units of, in different system of measurement. The first column is for pounds per ton, US tons, and the second one is is kilogram per metric tons. Okay, and yeah, the higher is the slope, the higher is the tractive effort, and you can see for 50 degrees or for 45 degrees, it is pretty big, right? You need this much power per US tons here, okay, to move the machine, okay, to overcome the resistance. All right. So, before we move on, remember power required, which is expressed in pounds, total resistance, which is expressed in pounds or pounds per US tons of machine weight, and also effective grade are all the same. So in the exam, in the homework, or in quizzes, if you see these words, remember, they are all the same. All right. So, let me silence my phone for a second. All right, so here's an exercise. The haul road from the borrow pit to the field has an adverse grade of 4%. Okay, wheel type hauling unit will be used on the job, and it is expected that the haul road rolling resistance will be 100 pounds per ton. Okay, so the rolling resistance is in this. Is measured is this. Now, the first thing we need to do is to convert it to the equivalent grade, right? Then we could add it with with the effective grade, okay, to have the sum of and by having the sum of the grades, we can we can find the effective grade. So it is important to consider two effective grades. Let's do it one by one. The first step is to convert 100 pounds per ton into the equivalent grade. If you remember, we simply divided by 20, so it is equal to 5%. So it's like we are adding 5% to the grade. For effective grade, when you are going, when you're hauling, when you're going up the hill, okay, let's say you're going up the hill. So we already had 4%, which is this guy, okay, and here we find 5%, okay. So you should add them together. But when you're going down, when you're returning, what happens is that the slope is helping you. So there will be less effective grade. So you should minus, you should do 5% minus the 4% of grade, okay? So when you're going up, it annoys you. There will be more, you're adding, there will be more effective grade. And when you're going down, it's helping you, so you should subtract it from the equivalent grade for rolling resistance. Okay. All right. So about haul routes, developing project haul routes is critical to machine productivity estimation. Like I said, the machine will move hundreds or tons of times on that hauling road. So when you have a poor condition hauling road, you should consider that you probably will have, when you're doing the estimates, you should consider that a poor condition, it means your hauling will take more time, you're less productive, and you will need more time to get the job done. Okay. So routes providing less grade resistance result in increased machine travel speed. Yeah, obviously. So compared with a level surface and a surface with some slope, it's not the best drawing, I'm sorry. So when you're comparing those two together, obviously, oops, let me redo the slope. Okay, so yeah, it is a lot easier moving on this surface and on a surface which has some slope. So the travel speed changes. That's why we should try to avoid, we should try to level the haul roads as much as we can to increase our productivity. So in planning a project, construction should always check several haul roads options before deciding on a final haul plan. Okay, so ideally we want all surfaces to be flat. Okay, we want to avoid this. We want it to be flat, and we want to use a surface which is not muddy, which is stable, and has a compacted surface to make it easier for the machines to move on it. All right. So I guess I can cover one more slide before we finish this lecture. One or two more slides. So torque and horsepower. I'm sure you have heard the word torque, but do you remember what it is? Torque is the force from a rotating object. So when you rotate an object very fast, okay, some force will be created, such as crankshift, or it is a twisting force. Okay, so that is torque, and the power exerted by a rotating object is the torque it exerts multiplied by the speed at which it rotates. So if you multiply torque with the revolution per minute, okay, in simple we call it RPM, you will have this equals the horsepower. So horsepower is a result of multiplying torque by the speed at which it is rotating. In other words, by having the horsepower, you can find the torque. Okay, and this is a constant. All right. I'll stop here. We'll continue the lecture next time. Thank you for your attention, and see you all next time.